If there is a lesson to learn from this morning, it's that you have to come up with a name. Okay, you can use Scaleup if you want to, but I tried for 2 different grant cycles through NSF to get funding with no success at all. Put in essentially the same proposal with the name, and I got funding actually from 2 different places. And the referee said, "What a great name." This actually is not the original name. The original name was Student-Centered Activities for Large Enrollment University Physics. It had to be activities because the only funding you could get back then from NSF was not for education research, but was for instructional materials development. So in fact, one of the complaints I had from the referees was, this is an awfully hefty evaluation component here that you're spending time on. Well, yeah, it was a research project. I just didn't explicitly mention that. I kind of like the new version. It originally also was large enrollment, and it turns out most of the adopters are smaller, maybe 50 or 60. And it's certainly no longer university physics. There's lots of high schools and middle schools, and you'll discover that physics is only about 1/3 of the installations. But in any case, the tricky part was coming up with another U word besides university. But I like this because the first part of the name, the acronym, talks about the space, like this, and then the second half talks about what goes on inside the space. Okay? This is the 4th iteration of Scale-Up classrooms at NC State. It will be open spring break, supposedly. Still waiting for that. Maybe by the end of the semester I'll actually move my class over into this space from the room we're in now, but it's a nice room if I ever get to use it. There's more than 250 universities and high schools that have adopted Scale-Up that I know of. There's actually probably at least twice that many, but I know of a couple hundred. And they're actually all over the place, all over the world even. So this is what I want us to do. I want to spend literally about half of our time talking about why you would even want to do this. Because it's not particularly easy. It turns out that it's fun to teach this way, but it's not easy. It takes a lot of work to put instructional materials together. And it's a little scary when you step into one of these rooms and you wonder about, so what's going to happen when I'm not running the show constantly? So there's got to be some reason to do this. And then we'll spend the last half talking about what you can do and how do we know if it works or not. All right? Feel free to interrupt anytime. I'm not used to talking for long periods of time without somebody asking me something that I really have to think hard about. So, which is one of the fun things about this sort of classroom. But feel free to interrupt. I recognize the irony in me lecturing to you about how you shouldn't lecture. Turns out you're special. You are. Okay. The problem is students aren't learning as much as we want them to. Any questions there? Okay. There's lots of evidence for this besides what we've seen. Probably one of the more well-known things is a study by Aram and Roxa from about 5 years ago, essentially showing that about 1/3 of students don't get much of anything out of college in terms of critical thinking and writing and reasoning and that sort of thing. So it's a little discouraging. There are other problems as well. You may have heard, and you may even have said, that students aren't as good as they used to be. That's actually true in a sense. Back in the dark ages, this is back when I graduated from high school, we had to watch TV by candlelight, right? Fewer than half of my peers went on to college with me. Okay, that's just the way it was way back then. But nowadays, people recognize that a college degree is sort of the ticket to the middle class. And so a lot more people go to college, and in fact, it's more than 20% more go now than used to. So what's that mean? Well, if you think about it, that 20%, not all of them, but most of them are from the lower part of whatever sort of scale you want to build. You have a normal distribution and you can talk about achievement or attitudes or background. A lot of the folks, not all of them, because we did add a lot more women than before, but many of these students are from the lower part of that curve. And so what that does is it shifts the average down a little bit from what it used to be. So it is true, on average, students aren't as good as they used to be. On the other hand, the students at the high end are probably better than ever before because of all the incredible resources that are available to them. But what that means is, and the hard part for us as teachers, is that the range of students that we are addressing now is substantially greater than ever before. Okay? Makes our job harder. So that's one thing to keep an eye of. Here's another problem. Of course, we know the solution to that problem. You just fail those people who shouldn't be here in the first place, right? We can't afford to do that. We can't afford to do that. This is actually a few years old now. This is from 2008. But what they did is they took the number of students that you would have in 9th grade in the U.S., back in 2001, which is a little over 4 million. And by the time you get some of them graduating from high school and some of them going to college and some of them majoring in the STEM, are you familiar with STEM? Science, technology, engineering, math. And then you get some of those graduating from STEM, you go from about 4 million ninth graders to less than 170,000 nationally. That's a pretty leaky pipeline. Okay? And we can't afford to fail the people that do get through here. Now, you don't want to lower the standards, because that's the easy solution, right? We just let everybody through. But that actually makes the problem worse, because then employers can't trust your degrees anymore, your diplomas, right? So we can't fail as many people as before. In fact, there's probably more of a demand for more and better skills than ever before. Here's the difficulty. The President's Council of Advisors on Science and Technology estimated to stay where we are, which is at the top or close to it, internationally, we have to produce about 1 million more STEM workers over the next decade. If you do the math, that's 100,000 more each year. We're graduating 170,000 now. You need another 100,000 on top of that to stay where we are. So you can't just fail people. We can't afford to do that. So we have to find, what do we do? Bigger brains than before, and we can't just filter them out. So what do we do about it? It's worse. There have been a whole bunch of surveys of employers, and they basically all say the same thing. We are not teaching our students the kinds of 21st century skills, they call them, that employers want. More than 80%, about 85% say that speaking is a very important skill, and fewer than 30% say that the graduates we're giving them are good at that. Teamsmanship, writing, ethical thinking, critical thinking, being able to apply knowledge, problem solving, evaluating information, which I think is really important nowadays. How can you trust what's on the web? We're just not doing our job according to the people who hire our graduates. Okay? So, not a good situation. Here's the real problem. My grandchildren. They're playing with a computer. I don't even know what they're doing. It looks like that might be a dinosaur right there. I can't quite tell. But anyway, they are playing with computers, and they have since they were little. And so they are what Mark Prensky has titled digital natives. They've been using technology just like we learn a language. If you're a little kid and you know, as you learn a language, you learn it so well that even though you probably don't even know the grammar rules, when you're a little kid certainly you don't, yet you can still communicate pretty well. I mean, it's fun to watch little kids say, house and houses, mouse and mouses. You know, we sort of laugh because they don't know all the rules, but they do really well. It's because our brains are very, very pliable and plastic when we're young. And that's when they are using technology. Okay? So I think it impacts that, not always in good ways. Kids these days, teens these days, average 9 hours per day using social media. That is scary if you ask me. Now that doesn't say that we're not also using a lot, I could see you out there checking your Facebook account. Okay? But probably not 9 hours a day. But they've been doing that for a good part of their lives. 92% of kids say they're online every day, and just about a quarter say they are online constantly. So it's just a different world than it used to be. The average young adult gets by less than 9 minutes before they have to send another text. So if you thought smoking was a bad habit. Okay, and this is from 2011, so that's actually a long time ago. That's 5 years old. My guess is the number is less than that. And of course, I mean, physicians are worried about this because this, I talk about waking hours, but they take their phones to bed. And at 3 o'clock in the morning, they'll go tweedle, 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 and they'll blink and roll over and read a text and text back and fall back asleep until they get a response. People are being treated for arthritis of the thumbs because they're they're just doing it all the time. So people are using technology in ways that we just never imagined. And it leads to different kinds of thinking about technology. This is how my students take notes. They take a picture. I mean, when you think about it, look at this. Can I embarrass you horribly?
Sure.
Sure, why not? Look at this. She is using mashed plant fibers. That was, what's that, Egypt maybe? 3000 BC or something? But she's got a special pigment stick here. It's coated in plastic so you don't get the pigment all over your fingers. Okay? I mean, that's the way, not quite, but students sort of think of it that way. If something's important, you take a picture of it. The first time I saw students doing that, which has been a while now, I went over to them, and I got my old man glasses out, and I said, can you actually see that? The screen is so small. They said, well, of course not. And they opened up their notebook. Oh, I should get over here because everybody in the back is, sorry. They opened up their notebook and they showed me, they had printed these things out, all these pictures they had taken, great big, and they'd written their own notes and comments right on the top. Brilliant. And I never would have thought of that, because I thought phones were these things that you use to talk to people. But in fact, that's just a minor use for today's kids. They have been using Google since they first learned to read. In fact, that may be how they learned to read. Well, I did a little search for the word Google on Google and found almost 12 billion hits, and it took less than 1/10 of a second. It's incredible. I mean, I use Google every day. I'm sure you do too. I still can't believe it. Because you know that if you can't find your search term in the first page or two, you just need to tweak what you're looking for. I mean, it's there. This isn't a chronological or alphabetical list or anything. It keeps track of what you've looked for in the past and makes some pretty sharp connections to what you're looking for now in ways that it might even be considered scary. So the world has changed. Anybody recognize what this is? Anybody know where that is? DC. It's DC. That's the Library of Congress. Okay? This is, believe it or not, this is the card catalog to the Library of Congress. How many people here want to admit to having used a card catalog? Okay? That percentage of hands gets smaller and smaller over time. Okay? When you think about it, card catalogs are incredibly archaic, but they worked. But it's changed the world. How do you check to see if a student has plagiarized something? You suspect that. What do? Yeah, you just grab some sentence that's way better than they can write, put quotes around it, stick it in Google, and in 0.09 seconds, up comes the very book that it came from. I mean, we can find their sources faster than they can, right? Because we can look for that specific thing. They don't seem to realize that, but we can. Imagine trying to figure out if plagiarism actually happened with the physical Library of Congress. I mean, it's totally impossible. You get the entire population of the planet to go flipping through the books of the Library of Congress, because you'd have to look at every single page, of course, and you'd never do it. Okay? Shouldn't that change the world somehow? Well, it has. But shouldn't it change education? It hasn't yet. Okay? My phone is better than the Library of Congress because it's more tightly indexed, and it sits in my pocket or on my belt. And that's what kids grow up with. They learn to read with Google. You have to know how to read in order to look up Angry Birds or whatever it is that you're trying to find. Of course, there are disadvantages to that. Yeah, it does affect our brains. Actually, there have been studies that show that people aren't as good at remembering things as they used to be, but they're better at remembering where to find the things. So, is that bad or not? I don't know. I used to be able to take a square root on paper, longhand. Wow, that's really useful. Anyway, what it means is that the kids today are used to living online, so much so that about 1/3 of all of our students are taking an online class this semester. And that's not just UNC Charlotte, that's nationally. I don't know what it is at UNC Charlotte, but it's probably close to this. You can see the green here is the total enrollment, and it's been around the 20 million mark for this decade. But look what's happened to the percentage online, from about 10% to about 1/3. Okay, so, and that just keeps going up. And it makes a lot of sense. Students go online for everything. So this is the way they gather information, is by getting it from online sources. What that means, however, is that this doesn't work very well for them, for most students. Actually, there's one person in this picture that's real happy about all this. Can you see them? Yep, there they are, right there. All the people in this room either paid money directly or had somebody pay it for them just to listen to them talk. No wonder we like to do that. Okay? Actually, this is a really nice lecture hall. I got this from a web page, from a university which will remain nameless, but it is near Chicago. How can you tell this is a contrived photo? This is fake. Yeah, they're all paying attention. Look at that. Even the people in the back. There's not a Sudoku screen out here, nothing at all. We know that this is really what happens. All right, so the biggest problem is that students are not learning as much as we want them to, but also they're not learning the kinds of things that we need to teach them, at least according to the people that are hiring them. Kids are different nowadays than they used to be. There's information and resources available that we've never had before. All those things together. And there are economic pressures. I mean, students can go and take classes from an online university that is accredited by the same places as accredit us. So what are we going to do when they come to UNC Charlotte and say, hey, I'm going to apply, but I want to apply as a junior because I got all of my freshman and sophomore classes out of the way online? Well, you know, we could say something like, well, you don't get the full student experience. And they'll say, oh, I don't care about that. I don't care about the football team. I don't care about fraternities. I'm trying to learn this. There has to be some value added to going to a university. Okay? Fortunately, there is. There is this interesting study done by Alexander Aston and actually a whole team of people. And it's such a gigantic study that they turned it into a book. This is a cover picture I grabbed from Amazon. You can buy this book. The title is What Matters in College. And that's what they tried to do. They surveyed, I think it was 20,000 students, and just tried to characterize the heck out of them. You know, what was it like when you were growing up? What's your obvious things, like what's, you know, socioeconomic status, race, gender? What's the highest level of education of your parents? What kind of reading material was in the home when you were growing up? And also things like, how many hours a week do you spend doing homework? Do you use the library? Do you participate in intramural sports? Do you do this? Do you work outside of class? You know, whatever. And what they did, this ended up being a highly cited work. In fact, it's one of the most frequently cited works of higher ed. They found one factor that correlated most strongly with success in college, as measured by things like graduation rates and GPA. Okay? So it's a pretty simple study. You just collect all this information and see what's correlating the most tightly with success. And they found one factor that far and away was greater than anything else: people. If there's somebody that cares about whether you will succeed or not, you tend to do better. If you have to call up grandma every other week and tell her how you're doing, there's a little bit of self-discipline there to do better. If you are working with a bunch of students who are working hard trying to learn the material, you'll probably work a little harder too. If you've got a professor who really cares about you and knows you by name, you might work a little bit more for them. Okay? I mean, there's no rocket science in that, I don't think. But that's our trump card, because you can't get that as good online. Okay? You can say, well, yeah, there's places like Facebook. You can have online relationships, but it's not the same. I mean, if Facebook was all we needed for relationships, there would be no need for college parties. And we already know from the Doonesbury cartoon that we have to have college parties. Okay? So people are wired to want to be face-to-face to folks. So what do we do about it? Well, we don't waste people's talents having them do things like this. Anybody recognize what this is? Yeah, it's a telephone switchboard. These are all the operators. We call that a network router nowadays. It's a little box about this big. And this is fun. I like this picture so much, I bought it online, of course, from the National Archives. And I had it blown up, and it's framed in my office. This is from the United States Veterans Bureau, it was called at the time. And this is a room, and it's filled with, I don't know if you've ever seen these before, vintage 1924 computers. Have you ever seen a 1924 computer before? There's a whole room full of them. And I'm not talking about the adding machines. I'm talking about the women that are running the adding machines. If you looked at their job description, it would say computer, because that's what they did. Must have been a deadly job. All day long, you know, punch, 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 ka-ching, ka-ching, punch, 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 ka-ching, ka-ching. Well, we don't do that anymore. I mean, it'd be ridiculous. Plug-in computers are faster, they're more accurate, they don't break, you call the IT folks, they'll fix it. If not, you just buy a new one. No healthcare problems to worry about. Okay? They don't ever take vacations. You may not get them to do exactly what you want, but that's true with people too. Okay? So we don't want to waste people's talents. And so if all we do is stand at the front and talk at people, we'll probably be replaced by an iPod talking at people. Because at least they can watch that at 2 o'clock in the morning when they're awake, instead of 9 o'clock in the morning when they're having a hard time staying awake. They can watch it in their underwear. They're a lot more comfortable. They can play it back when your sterling, exciting, enthusiastic lecture mode puts them to sleep. They can back it up and play it again. And they're used to getting information online, so it fits the way they work. If we can all of our fantastic lectures and make them available online, that frees up classrooms to do this kind of stuff. Anybody recognize this is a tiny, tiny piece of a quite sizable painting? Anybody recognize the painting? School of Athens, Raphael, Socrates asking questions. Okay, Zeno here doesn't look real impressed, but in any case, if we don't have to stand and deliver content all the time, we can interact with the students. We know that's the thing that works. It's the thing that matters. And we can get them thinking in ways that they don't if they're just sitting there passively copying things down. There have been lots of studies that show that this sort of active learning works. There's been 2 different fairly recent meta-analyses. This one here has been submitted, it hasn't even been approved yet, so to speak. But they both show that active learning seems, this is force concept inventory, this is force and motion conceptual evaluation. So they're physics concept tests. And basically, in active learning, students learn a lot more. They're able to perform better on those tests. And similar things for this one. So this is a meta-analysis of a bunch of studies, and actually so is this. So we know from lots of research that active learning helps. So we know there's these problems. Primarily, students don't learn what we want. And we know that active learning with caring people helps. Okay? I think it's fun to consider this. So if you will beg my indulgence, I'm going to give you a little bit of a history lesson on how we got into using our lecture halls as instructional spaces, because it wasn't that way initially. This is the Theater of Dionysus in Athens, built about 500 BC. Okay? And I've been told by people that have been there that you can stand in this area here, this is called the orchestra, and talk with a voice about like mine, without a microphone, and you can be heard way up here in the cheap stone seats. Okay? Really worked very well. Well, in fact, here's the Greek name for this seating area. This is technically the beholding area in Greek. This is where you would sit to behold the spectacle down here. Whoops, sorry, just gave away all the secrets. Back it up here. Well, here we go. Sorry. Forget everything you just saw. Anybody know enough Greek to translate that? Theatron, theater. That means beholding area. This is the Theater of Dionysus. Dionysus was one of their gods or goddesses of wine, I think. And that's what went on down here. They would have religious festivals, or they'd have the Greek tragedies and that kind of stuff. So entertainment. And when the Romans came along, they also used it for that sort of thing. They focused on not beholding, but listening. So this is auditory. And the people that did the listening were the audience. Okay? Same idea. Worked great. And in fact, they were not used for education. If you were to ask an ancient Roman or somebody from ancient Greece, hey, have you ever thought of using one of those spaces for teaching people? They would not have, besides the language problem, they would not have understood why you were even asking that question, because that is not how education worked. Back then, you had a teacher and a handful of people, maybe called disciples, who would learn from them. Okay? If you think education is elite now, there's just no comparison back then. A very, very limited number of people had any kind of education to speak of. But when they did educate, they had these disciples with the masters. Here's Pythagoras. Here's our buddy Socrates, Plato, Aristotle. And they did education recognizing what matters. Relationships, social interaction. So that raises the question, what happened? How did we start using the auditorium spaces or these theater spaces as lecture halls? Turns out, as far as I can tell, you can pin it down to a time, place, and an individual. You can blame the church. This is Pope Gregory VII. And in 1079, he got a visitation here. There it is. And he came up with a great idea, which really was a great idea. We need to educate these priests. Because back then, life was tough. And if you could get a job as a clergyman, and it actually still is in the Catholic Church, a male sort of thing, but if you could get a job as a clergy person, you were set. I mean, people would be bringing you money instead of you slaving away trying to make money, or by working on somebody else's land or something. It's a great life. And so a lot of people wanted to do it. And Gregory recognized, hey, I need to make sure everybody follows the dogma. I need to get this information out to a lot of people in a highly accurate, high fidelity, if you want to think of it that way, kind of way. As far as I can tell, this is the first time in history that a large number of people needed to be educated at one time. Okay? Is it too early in the day for a bad pun? As far as I can tell, this is the first example of mass education. I warned you. I did warn you. The problem, of course, is that this is almost 400 years before Gutenberg got in trouble with the church, with the printing press. So what do? It turns out they were brilliant, actually. They thought about who is it that we are trying to train, what kind of skills do they bring, and what kind of facilities are available for us to train those people in. I mean, they didn't use those terms, but that's what they did. Absolutely brilliant solution. The monks, the people they were trying to train, were unbelievably good at copying. I mean, there were people who would spend 70 years copying scripture, which we might think is crazy, but there are people who spend 40 years studying the scripture that they've copied, and they've found that the copies are incredibly, incredibly accurate. They were really, really good at it, okay? So the monks are, the people we want to educate are really good at copying, and where did they live? In monasteries, and those monasteries had auditorium spaces, because not for the plays, but for religious purposes. Hey, that's a facility. Let's take all those monks and put them in the beholding area. Oops, that's interesting. No graphic at all. I just updated my software, can you tell? What I had up here was, there's a famous painting of a lecture hall from this time, and it shows people going like this and whatever. But the idea was, they would hire a reader. The word is lecturer now. The word lecturer actually means reader, not speaker. They would come in, they would open their manuscript, handwritten book, because there weren't any printing presses, and they would literally read line by line by line, and all those faithful monks in the beholding area would copy it line by line by line. And you couldn't leave things out, and you couldn't add things in. You'd actually be fined if you did, if you were the lecturer. But at the end of the instruction, all those faithful monks would then have their own manuscripts, and they could go hire themselves out as lecturers, sort of like we do now. And in fact, it is sort of like we do now. 1,000 years later, there's a lot better ways to get information out to people. Lecturing doesn't fit very well with how most people learn. There's been lots of studies of this. One of the more interesting ones is they looked at heart rate. And they found out that it drops pretty fast. If you can get people's attention for 30 minutes, you're doing well, and I recognize that that's about how long we've gone now. So 30 minutes is tops. You're lucky at 15. Attention spans are pretty bad nowadays. And I thought it was clever the way they did this. They just put little, I don't know if they did it with an ankle band or fingertip thing or what. But you don't want to have some person come in every 5 minutes and go, okay, who's paying attention? 1, 2, 3. You had to find a way to do it in a non-obtrusive way. But lecturing doesn't work very well for most people. It does work quite well for a few. Anybody know who they are? Faculty, that's right, us. We succeeded in academia. If you're honest with yourself, you will recognize that you are probably one of the best students you've ever seen. I mean, think about it. And if you're not willing to go that far, I bet you are willing to say, well, I may not have been the best student ever, but I sure wish my students were as dedicated as I was. Well, guess what? They're not. Okay? A few of them are, a couple percent even, but most of them are not. Right? So we have to, and remember, we can't just fail them. We can't afford to do that. So what are we going to do about it? Well, that's what we need to talk about now. Right? So is everybody happy with the context? The world is different. There's more information than ever before. Times are tough. Right? We have to teach a broader range of people when we can't fail them, or at least we have to be able to teach them better than we are. So what can we do? Well, that's where Scaleup and there's lots of approaches to this. That's where Scaleup came in. I intentionally redesigned our facilities to build up the possibility for interactions, because that's what seems to matter, according to Aston and his group. And so that meant these funny round tables here, or these kind of D-shaped tables here for smaller classes. And so that's what we did. Let's look a little bit more closely at that. For big classes, tables that are 7 feet in diameter. You might say, well, that's pretty prescriptive, and it only seems that way because it is. I tried 6-foot tables and 7-foot tables and 9-foot tables and 10-foot tables, and I had people taking field notes of students as they were interacting across tables. If we're 10 feet apart, I'm not going to embarrass you this time, I hope. If we're 10 feet apart, we have to talk pretty loudly to be heard. And if we're talking loudly at our table to be heard, guess what has to happen at the next table? They have to talk loudly too. Well, if these two tables are talking loudly, guess what happens over there? And the sound level just blows up. Besides the fact that if you have a 10-foot table and you drop your pencil, guess where it rolls? 5 feet away from you, okay, to the center. So we just tried a bunch of different sizes. 6 feet is too tight, which is unfortunate because that's the standard size. You go into pretty much any hotel and ask for a round table and they'll roll out a 6-footer for you. And in fact, the first iteration of this, I borrowed tables from a hotel and tried them and found they were too tight. We tried the 9 and 10-foot tables. Besides the noise problem, we just couldn't pack enough in the space. There's too much unusable space in the middle of a table. So 7 foot seemed to be a pretty nice compromise. We found it's actually better to put the teacher station in the center. One, that discourages lecturing, because if you stand here and lecture, then part of the class is behind you, and that feels icky. So at the very least, it gets you to look around a little bit, and that sort of breaks what I'm doing right now. I'm only doing that because of this microphone, and you folks in the back row who would complain otherwise. Okay. And then there's 3 teams of 3 students, which we label A, B, and C at each table. Okay. For smaller classes, then we sort of use these D-shaped tables that are kind of a 5-foot square with a 5-foot half circle. And then you can stick an LCD. You can tell this came up later. When I first started doing Scaleup, there weren't any LCD screens that you could buy. And then you put 2 teams at each table. Okay. And then you surround the space with whiteboards as public thinking spaces. And then the idea is that while the students are working on these boards, that frees the instructor to roam around, listen in on conversations, look at whiteboards, start arguments, get people to justify their work, make them think. Okay? That's because you don't spend your whole time delivering content. It's available outside of class, and that's the way students are used to gathering content. And you're trying to teach them to be lifelong learners anyway. When I am teaching graduate students to teach this way, and I see one who is spending too much time sort of answering questions, I'll pull them to the side and I'll say, okay, what you're doing is fine, because you're basically training the student to come to you and you'll answer their questions. That's fine if you plan on following them around for the rest of their life and answering questions for them. If you don't want to do that, maybe you need to help them learn to answer questions themselves. And so by the end of the semester, I tell my students, I want you to not need me anymore by the end of the semester. Yes?
What sort of questions do you ask the students to get them into? Because I've noticed with my classes, in their homework assignments or whatever it is, I try to encourage them to think and figure it out a little bit on their own, and they complain about that.
Yep. Yeah, I have some examples of those that I will show you in just a couple of screens here. Okay, so hold that thought, that's a good one. You don't want to ask them just questions where the answer is 5. Okay, you have to have something where, well, the answer might be 5 if you make these assumptions, but if you make these other assumptions, which are perfectly reasonable, you might get 4.5. Well, is 4.5 different enough from 5 to worry about? Well, so it has to be something where there's something to debate. Not always, but sometimes. In fact, there are times when everybody's going to do it the same way. Because there's just some standard things they have to be able to do. Then you don't want to have them put that up on the big public whiteboard space, especially if you've trained them to look around the room, because as soon as the first group is done, everybody's done. Okay? So for those, I have these smaller group size whiteboards. You go to Lowe's and buy a sheet of bathroom wallboard and cut it into 10 pieces. And in fact, this is a picture of a student board. I just saw it in class. I said, well, that's kind of neat. Click. Students used to complain because I make them do all their work on whiteboards like this, because it's big enough that way I can see it as I walk by. They can show it to everybody else more easily, and and they have to work as a team together because there's only one whiteboard for the whole group. They used to complain because after we were done with the problem, they'd have to quick write everything down. Why don't they complain about that anymore? Yeah, they just take a picture of it. Okay, technology solved that problem. Everybody's got a name tag. Nobody's anonymous in my class, even with 100 students. They think, within 2 days, they think I know everybody by name, which is really amazing. And the way that happens is I do this. I walk around and I talk to the class, and then I go, all right, what do you think about this? Sandy, tell us what you think. What people don't realize is that I just learned Sandy's name as I walked past. And I remember it long enough to get over here. But guess what? I now know Sandy's name. Okay, so I'll do this over here, and I'll walk around and say, okay, Dan, what do you think? At this point, everybody says, holy cow, that guy knows everybody's name. Especially if at the beginning before classes start, I look at a roster of student pictures and I memorize half a dozen. So when they come in, I'll go, Sally, right? You're Joe? And they think within the first week you know 100 people by name, and you don't. But guess what? Within about 3 weeks, you do. That's Dan, that's Sandy. See? You can also see we've got some fairly famous alumni. You also notice that those are color-coded. You can't let students take name tags with them. That works fine. What doesn't work is having them bring them back, right? Do you know how long it takes me to hand out 99 name tags? I timed it. This semester, I was curious. I timed it. 40 seconds. Because I just open up my little cabinet. There's a stack of name tags with a rubber band around it. I take the rubber band off, and I scan out the first batch until they're no longer just red ones. They're all printed in red for table 1, and I plop them down on Sandy's desk, or Sandy's table, and she hands them out. And then here's some blue ones. I'll hand them out here. Here's the green ones. I don't even have to read the names. And I can hand them out in 40 seconds and collect them in about the same amount of time. When you collect them, you just tell the students, stack them up, and you walk around and collect them and put the rubber band around it, and it's ready for next time. Okay? That goes a long ways towards personalizing the class, because they think that you know them, and in fact, you do get to know them pretty quickly. I have a homework lottery. I teach physics, and we do have lots of problems. And so I use a system called WebAssign. I don't know if you've heard of it or not, but it's actually another spin-off of my research group. And so each individual student gets the same problem, but with different numbers. Okay? Because I know they're going to work together, but they can't just say, hey, the answer to the first problem is 42, or whatever it is for the hitchhiker. Isn't that the Hitchhiker's Guide answer, 42? They have to say, well, on this problem, you have to take this mass and divide it by this, and this mass here, and recognize this distance like this. Basically, they have to explain to each other how to do the problems, because everybody's numbers are different. That's fine. And then what I will do, because I'm actually as interested in their approach as in the number, I let the computer check the accuracy of the number, but then I will roll. I've got a 12-sided Dungeons and Dragons die, and it looks like table 4 has to hand in the written solutions. If they don't have them, or they haven't done a good enough job, I will delete the electronic credit for that homework. And they'll gripe and whine and complain, and I'll say, you find me someone who's willing to drive across the bridge that you've designed that you can't show that is actually strong enough to hold their car. They learn. I've got engineers, so I can harass them that way constantly. Okay. It's a lottery, by the way, because I do use this with 12-sided die, and you'll notice that there's a 12 here. I've only got 11 tables in my classroom. So if a 12 comes up, everybody gets credit. And for whatever reason, that makes this incredibly exciting. I don't know why. So if I roll the die and it doesn't stop under the camera, I have to roll it again, because I could be cheating them. I don't know. Here's something that I came up with that surprised me. I thought it would work. I didn't realize it would work the way that it did. After many of the activities, I will tell the students, after we do an activity, take your notebook and pass it to the person on your right, which is easy to do at a round table. Okay? Spend 2 minutes and summarize what we just did. What's the takeaway? Why did we do that? What's the important thing? And then when you're done, pass it back. The first thing that came up, what I wanted people to do was to think about what was important, get some, communicate. Remember those skills that the employers want? Write these things down. And then when you get that notebook back, you are then evaluating that. If you're familiar with Bloom's taxonomy, this is all good stuff way up high. The first thing that surprised me was they wanted more time than 2 minutes. They were taking this very seriously because they were writing in their friends' notebooks. This is what their friends would study from. That's neat. Okay? But what happened next is what really surprised me. I was not expecting this. Rather than me saying, okay, these are the key points that I hope you've got. Instead, I said, who's got something good? Okay? So people would raise their hand and they would read what was in their notebook. One nice thing about that is it allows everybody, even the weak students, to present, because they didn't have to write the stuff. Okay? But it also, let's say Coral, right? Coral? Let's say she raises her hand and says, blah, 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 blah. Whatever Dan wrote, okay? Not only has she evaluated what was important, shared it with the class, she's also implicitly told the entire class, I think what Dan did was so good, it's worth sharing. How often do students have opportunities to praise each other publicly for high-quality academic work? It made a huge difference in the feeling of the class, okay? And I wasn't expecting that at all, but it was really neat to see. Well, then we talk about it. We would talk about it. I very rarely say no. Okay. Most of the time, in fact, because I do education research, I know where a lot of the mistakes lie. And so if people don't bring them up, I will. and then we talk about them. Oh, people might say such and such. Does anybody see anything wrong with that? Or, that's, what led you to that idea? And, so you bring stuff out explicitly if it's not mentioned by itself. Let's look at this UP. Remember upside down pedagogies? First of all, it's a flipped classroom, which means that things that used to be done in school, primarily content delivery, now happen at home or the dorm or an apartment online, okay? And things that used to happen at home, like totally impossible homework problems, are done in school where there's teams of people out there and the instructor to help. Now, you don't help them with everything, but it's a reversal. Okay, that's why they call it a flipped classroom. Incidentally, Lage, Platt, and Treglitz first came up with the phrase flipped classroom in the year 2000. I mean, people have been doing it a long time, but they were the first ones that came up with that phrase, which I think is really pretty useful. It's also backwards in the sense that a lot of the teaching that's going on is being done by the students. There is nothing better than a sharp student to explain something else to somebody else, to another student. They can use the same cultural touch points. They use the same weird words. They can refer to the same YouTube videos and the same TV shows that I don't even know are on, okay, and explain things. And it's somebody who's just figured it out. It's been 35 years since I struggled with Newton's third law. I literally do not think the way that I thought before I understood it. So I have a really hard time not, how can you possibly not understand this? It's intuitively obvious, and it has been for 35 years. I don't say that, but that's why it's intuitively obvious. But you get somebody who's just figured it out and they can say, oh yeah, that's what I thought, but then I realized blah, 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 blah. So having students explain things to other students, there's a lot of cognitive science behind why that works. We can talk about more if you want. And finally, it's backwards design. In order to create instruction materials, you actually start at the end. Think about what you want students to be able to do at the end of the day, end of the class, end of the semester, end of the course sequence, end of the degree program. You can make any kind of grain size you want, but it's in terms of performance. The word understand isn't there because nobody knows what that means. And that's actually the hard part, because we like to say, well, students should understand such and such. Well, what's that mean? Well, the way I think about it is, I imagine I walk past a student and they're doing some work on a whiteboard, and I look down and I think to myself, they have a good handle on this, they do understand. Well, what was it that they were doing that could convince me of that? That's the performance outcome. If students can do that particular thing, they will have demonstrated their understanding. Students love this, because you give them those at the beginning of the semester, section by section by section in the textbook, if that's what you're doing, or whatever, but really, really specific, and you just tell them, the more of these that you can do, the better your grade. Pretty straightforward. It's not a guessing game. You don't have to wonder what I think is important. There it is. Okay? Then, of course, you do things like not cover all of them in class, unless somebody brings them up. And then on the first test, you make sure that some things that were not discussed in class go on that first test. And then you get a student, it's always a male student, I don't know why. They always storm in after the first test and sit down with their arms crossed. And you ask them how the test went, and their hand is always up first, and they say, such and such was on the test, and we didn't cover it in class. To which my response is, why not? If they don't understand something, they have a responsibility to ask about it. And if they don't, I have to assume that they can do it. Okay? And anyway, what that does is that once you have these listed out, it makes creating these assessments very easy. If you think students should be able to do such and such, then you write some problems that have them do such and such. In a sense, you're telling them what's on the test. I mean, you're not giving them the specific problems, but they know this is exactly what I need to be able to do. Students love that. Okay? And once you have that, then you finally get around, you see why it's backwards? Then you finally get around to thinking about, well, what resources do I have to provide? What kinds of things do students have to be able to do to practice, to be able to do these things? So then you start writing the instructions. Okay? You may have heard these things called learning objectives. I don't know what either one of those words means, so I call them performance outcomes. Whoops, what's a typical class like? Well, I've got typical in quotes because there's no such thing. For me at NC State, I started with 3 hours of lecture and 2 hours of lab, one instructor, 100 students, and one graduate student who taught 4 labs at 25. And I was told, that's your world, you can play with it any way you want, but you ain't getting no more resources. Okay, I've got 5 hours of class to work with, 2 hours Monday, 2 hours Wednesday, an hour Friday. 5 hours of class. There's no distinction between lecture and lab. First of all, there's very little lecturing. There's some, but very little. Okay? Most of the class time is spent doing these activities. So they actually have more hands-on stuff than they did when they had labs. And it's always synchronized. The problem with having lectures and labs, the biggest problem, I think, is it's hard to keep them synced up. Because there's students taking lab on Monday, and there's students taking lab on Friday, and you taught the material on Wednesday. Well, seeing it for the first time through experience, or using experience to validate something that they should already know, those are opposite things. Induction versus deduction kinds of stuff. And you probably aren't teaching them differently, even though they're very, very different cognitively. So the solution, of course, that everybody knows, is you just delay the lab a week and everybody's out of sync. Okay? Well, instead, in Scaleup, you just sort of float back and forth. If it's time for them to do an activity, in fact, if everything goes well, students will ask the question that you wanted them to ask, that you sort of set them up. And then you say, oh, wow, that's an interesting question. What would it take for you to answer that? What kind of equipment would you need? What sort of measurements would you have to take? There's stuff over there, equipment over there. Go grab what you need. And then you roam around and ask embarrassing questions. Okay? Very different. I do use lecturing for some things because it's great to help students organize the material because they haven't learned how to read topic sentences yet, I guess. And believe it or not, they don't get motivated reading a textbook. Doesn't happen. But you can get them motivated. You know, they come in and you can say, hey, I just read where they found a 3,000th planet. How do you suppose they do that when you can't actually see most of them? Hey, guess what we're going to do today? Blah, blah, blah. And then we do activities. So this is getting back, believe it or not, finally, to your question. What kinds of things do you have them do? We'll talk about that. Tangibles are hands-on measurements. Ponderables are interesting questions. Visibles are simulations, in my class at least. And you talk about it, and you do more. These take 10 to 15, 20 minutes. Do more. Just keep circulating until you're all done, and you wrap it up. Okay, roughly. So, what's a typical tangible? Here's one for the very first day of class when we haven't had any physics yet. How thick is one page from your textbook? How would you do that? You just take a whole stack of them and you say, well, I don't know, that's like an inch divided up. Well, we talk about that. That's actually a good approach. But why do you take a bunch? Well, because we've got a standard in our head for this and not for that tiny, tiny thing. And every factor of 10 that you go up in the number of pages, you add a significant figure to your estimate of thickness. In the real world, you pay money for significant figures. So we talk about that. And then the next question is, well, okay, now you know how thick a page is. What's the diameter of a period on that page? How do you do that? Well, you just stack up a bunch of pages till you can cover up the period. So we talk about standards. So lots of things like that. Universal product codes, figure out how to read those without going on the web to look at the specs. Figure out how to read those. I'd have them do this right before we do atomic spectra. Those of you that are in the sciences would know why, because it's basically pattern matching. You ever take a piece of Scotch tape and pull it either off of the roll or off a table or something, and it's really annoying because it wraps itself around your arm? It does that because you have separated electrical charges. And the question is, okay, how many extra electrons are there on that piece of tape? And that's all the information that's given. We have the little aluminum blocks that they put their name tags in. They hold it in your hand and it warms up. What's the power output of your hand while you're doing that? I'm going to skip past that. Those are just some more examples. Okay, here's some ponderables. You ever go bowling and you notice that the ball skids at first and then rolls a little and then skids less and rolls more? How far does it get before it's just rolling? And right away somebody will raise their hand and say, oh, it's got to be less than 60 feet. How do they know that? That's how long a bowling alley is, and they've seen it happen. I tell them, I teach them, when you are doing a problem, it's always good to know the answer before you start. I mean, if you get 6,000 feet, you know there's something wrong, right? That's a good approach. This next one is actually from an exam. You know where I'm from. You know, there's Duke, Carolina, and NC State. Anytime any two of those three teams play basketball, it pretty much shuts down the world. And so one of these exams was around that time. Must have been in March. And so I said, you know, on the test, it was a fairly long problem, but you're in a hurry to get home, just because you're going to have friends over to watch the game, and you realize at the last minute, oh man, I forgot snacks. What happens when you run into the store and grab a cart and you're in a hurry? You get the stupid one with the floppy wheel that does this, right? And so you're sort of cursing your luck as you push against this walking down the candy aisle, and you wonder, gee, what fraction of a candy bar am I burning up while I do that? This is a fun one. Is residential solar electricity feasible in Raleigh? What's the key word in that question? Feasible, yeah. What does this mean? Economically, yeah. And in terms of space as well. So I can tell, you were wondering, how do you get them to do things? I can tell it's a good activity or a good day when nobody leaves. I give them a 10-minute break during a 2-hour class. If nobody leaves during the break, it's a good class. This is something from political science. You just pick some current event and send the A groups off to see what Fox News says about it. The B groups go off to see what MSNBC says about it. And the C groups go off to see what the BBC says about it. Same topic. So I just did this at random. I picked one day and I said, okay, what does Fox News have to say about Obamacare? Well, it's a Band-Aid, and they're throwing another Band-Aid to the millions of people who have been wounded by the Affordable Care Act when they were booted from their existing health coverage. That's what Fox News says. MSNBC says, same day, oh, the Affordable Care Act enrollment figures were released on February, and for the most part, the numbers look pretty good for those hoping to see the U.S. system succeed. And the BBC has to explain what Obamacare is. Okay? But it's different, okay? Then what you have the students do is, they compare notes, and then they each pick their own politically charged current event, scour the web, learn as much about it as they can, and then pretend they are working for one of those media outlets and write the report. Give it to somebody else and see if they can figure out who they're working for. Okay. Do you see how that's sort of like the physics things? You take the content, you learn something about it, and then you apply it in some interesting way. Here's a visible. We give the students a real spring and a real ball, and they make measurements and analyze it, and then their task is to write a computer program that simulates it. So this is actual output from a real student program. In fact, this right here is the entire program right there that creates all that beautiful simulation with the spring and the ball and the little specular reflection. This is 3D. You can spin it around. And the physics is right there. 4 lines. Okay? Anyway, so does it work? We have data from multiple schools for all of these. You'll be glad to know that I didn't bring all of it, but I brought some. I did this in physics, I'm sorry, that's what I do. First semester of physics is on mechanics, and I compared something called the normalized gain. It's basically the percentage of possible progress. Normalized, which means I can compare Harvard students and MIT students and NC State students, even though they start in very different places. I'm looking at how much did they learn of what was available for them to learn. MIT students start up a lot closer to the final than the NC State students. In lectures, it was this. For the force concept inventory test at NC State, Scaleup was that. University of Central Florida, same test. Different test, Rochester. Okay, that's good. Then because of the way I create groups, I was able to analyze this in terms of the bottom, the middle, and the top thirds of the class. So that's the same data, just divided into thirds. What do you notice? Who gains the most? The top students. How come? Because they're teaching the weaker students. That's important because a lot of what the complaints are of the naysayers that say, this is a lot of work and a lot of money, why bother doing this? You're ignoring the best students, the cream of the crop, the stars of tomorrow, to help these weaker students who shouldn't even be here at all, remember? Well, if you can get those top students to teach the weaker students, that cream of the crop gets even creamier. Okay? Here's the same information for the second semester of physics. 3 different tests, 2 different schools, same pattern. So just for fun, there's all that data together. So this is 2 different physics courses, 1, 2, 3, 4 different schools. I don't even know how many different teachers, lots of different assessment tests, but the pattern is the same. In fact, it's most pronounced for MIT. The top students at MIT are the best students in the world. If you can get them to go to lecture, they're not going to learn much. They already know all that. But if you can get them to explain things to their peers, they learn a lot. Here's one data that I got myself in trouble for. I went to the lecturing faculty at NC State in physics and said, hey, give me the test that you give your students. And I randomly picked problems and gave them to my students, and you can see what happened. Isn't that embarrassing? My students did better on your test than your students did by like a letter grade. I mean, this is a big difference. This is statistically significant. Except on this one. For that problem, they didn't do as well. I thought, well, that's a little weird. And I went and looked. And remember, I pulled these off randomly because it wouldn't be fair otherwise. And I just happened to have pulled off a problem that the Scaleup students had not had yet. So then what's embarrassing is that they still did almost as well as the people that had it. That's because they have been trained in how to solve problems that you don't know how to do. This is the best data that I've got. assessment person, this is for you. Single email to the University Assessment Office, and I said, I want data from the last 5 years of intro physics. I got data, within 3 days I got an Excel spreadsheet with 16,000 students and what course they took and what grade they got and demographics. And look, overall the failure rate was about 18%. It went down to about 6%, 7%. For women, it dropped by a factor of 5. For African Americans, it dropped by a factor of 4. There are, you see these little uncertainty bars. People usually call these error bars, but they're not errors, they're uncertainties. That's another lecture. You don't see them over here because with 16,000 students, you're not going to see them. You see them for this because there weren't that many Native Americans in the sample. Here, you'll notice not a single Hispanic student failed in a Scaleup class over this 5-year time span. What I find exciting, I think the most exciting data for Scaleup is the fact that basically within the uncertainties, the demographics wash out. It just doesn't matter anymore. You can be a member of an underrepresented group or not, it doesn't matter. Clemson, they were having problems with their calculus, their D and F and withdrawal rates were 44%. Within a semester, they cut them in half. And so now they've got more than a dozen Scaleup classrooms. They teach all their intro math this way now, up through and including differential equations. MIT, they did a lot of data. They looked a year and a half later, and they could still pick out the students that they call theirs TEAL, Technology Enhanced Active Learning, but it's Scaleup. They could still, a year and a half later, pick out students just by achievement on concept tests. So, where are we now? Lots of places. Here's MIT, this is Iowa. They teach 60 different content areas in Iowa. Minnesota has an entire building full of these things. 10,000 students a year take an active learning class, they call it. Most of the implementations, a little over a third, are physics, because that's what we started in, but it's expanding. I think some of the more interesting ones are here in humanities. Somebody was teaching ancient history, and so the homework was to go and read Herodotus, famous historian, about, I don't even know what the battle was, but some description of a battle. Okay, that was their homework, so they learned about that. They come to class, and the teacher had taken a Grecian urn and the artwork on the urn and photographed it in a way, sort of unwrapped it. You know what I'm talking about? And so it was the same battle. So the student's task was to compare what Herodotus said to what was on the urn. And they found that the urn was propaganda. They did that back then? Okay. But again, you can see the general approach. They come to class well prepared. They have to have homework on that stuff or they won't do it. They come to class well prepared, and then you have them do interesting things with that knowledge. And this is in hundreds of institutions. Biggest that I know of is 603 students in one classroom. I don't recommend that, but they're doing it in Australia. So the name says it all. It's student-centered. They're doing active learning, and the environment supports that. And there's upside-down pedagogy going on within the classroom. Okay? I am about as much overtime as I started, which was 6 minutes later. If you have questions, you can email me, obviously. You can call or just drive over. You can go to this website, although not today. I hired a consultant to rebuild it. Supposedly Monday, he's going to be coming in and saying, here it is, ready to go. But soon, you'll be able to go to this website. There's a couple of hundred different sites, and you can search. Show me who's teaching nursing this way. Boom, boom, boom. Show me the people that are in North Carolina that are teaching this way. Boom, boom, boom. And contact information, pictures of their classrooms, stuff like that. And if you email me and ask for access, I will give you a password that gets you to about 100 research papers, plus instructional materials in physics, biology, chemistry, stuff like that, plus a lot of detail about how to break the students up into groups. How do you train people to teach this way? How do you train students to learn this way? All that kind of stuff is available on the website.